keep the audio and try to do something. So for this question, I'll also do a screencast and put on YouTube so you can review it later if you really have this. So this one basically is what the example in class is. So how are we going to do this? So write a single function to calculate the amount of chemical need to make a molar solution for potassium acetate. This actually, I think last time this we actually asked you to put a name, but it, so if we go back to the classroom example. It's basically asking to modify this code. So, and the exam says ask you to do potassium sodium hydroxide. Oh, we already put it in here, sodium hydroxide. And then the other one is the potassium sulfate. That probably should be 4. And this one is 40,74.259. Basically put a matching, that's the answer for this exam, for this question. Okay, so for this exercise, the question is to ask you to write a function to calculate the amount of chemical need for a molar solution using for potassium acetate, sodium hydroxide, and potassium sulfate. So you can modify the third molar solution example in class and just added those. So I just added sodium hydroxide, which is 40, potassium sulfate 74, and then I forgot the other one, potassium acetate. That one is a 98.15. This should just work. We run this. And for the example, that would be, say, oh, we should put this formula there instead of the name like this. So this should be the formula. And after I run after I had defined the function, and then I just call the function called molar solution. The first one is 100, and then 10, and then sodium hydroxide. That will be for this one. Oh, that should be molar solution 3. The second one should be 150, 5 molar. Oh, that's not 2. And this should be potassium sulfate. last one need to be 500, one minimum. Potassium acetate. And if we run all this, oh. There's an error. Where's my mistake? Who can find my mistake? I put the number as a quote, so number should have been put in the quote. So when I type it, I type a quote. So okay, let's rerun this. Okay, now it's working. So this one, for this exercise, you just need to figure out how the name, and in fact, it's probably much easier if you type it this way. Just put the number and chemicals in the same order. That way, it's become more clear. That's first one and the second one. The second one, it's just one explanation. Say, in this one I have two. So you need to pay. Well. Oh.
Sorry, this is kind of off topic, but do you mind if I record your lectures? It's easier for me to like go back and listen at home when I record you here.
I'm recording here.
Okay.
I'll just upload.
And you upload it?
Right.
Okay.
Yeah, I will. So,
okay.
so well, if you feel you recording, I can also upload yours for the whole class. So, yeah, maybe your device is better, has better quality. So, yeah, that's fine. I don't mind that.
Okay.
So I clear up everything on the right, so there's nothing there. So after I run x and y, now I see y x15, y20, and then now the key is everything inside of this, that's happen inside of this scope. This is scope of this function. So we have a y happening here, which is modified by the input function of x. So we can run this. Then we define the function call. Then we call this function. Yeah. So we calculate the z. So there must be a temporary y there. In fact, I probably just to make it fun, let's do this. So I'm going to say print. Say inside y. So that's actually, let's do this. Yeah. So now inside y is 8.5, but outside the y is still 20. So maybe repeat this again and recall it. See. Okay. Okay, this is the example. Try to demonstrate the scope of a variable in R. So first, let's clear everything in the current working space. So right now on my upper right, there's nothing there. So if I run these two lines, then we have two variables there in the memory. One is x for 15, y for 20. Now then I define a function called test. This test will input one parameter x and then modify it and assign it to another variable called y. Now, to show the difference between the outside and inside the function, I actually print out the y inside of the function. So then you can see the value of this internal y. Now, I call this function using x and then assign it to z. So after I run this, you should be able to see internal value of y there. So in fact, the internal value of y is 8.5. But look at this. On my right, the current value of y is still 20. So that's still 20. In fact, we can print out here. There. So x is 15, y is 20, and z is still 8.5. So what this says is, so this y inside of the function test, it is only occur inside of the curly. That's within the function, and that's what happened inside of this function is isolated from outside. Okay. Yeah. I may update this one since I have changed it. I'm going to update this. 0917. That way I know I changed or modified. So number 1, 2, 3. Number 3 is x by z. This one is a bit complicated, so I'm going to skip this one. So, because we haven't, I think we didn't go through the lecture this time. So I'm going to skip this one for this class. If we have to write it, it basically become an if-else. Oops, we did it wrong. If we have to write this, well, since we are working on, let's just do this. So, write function, where we have a data called that. Contain two column x and z, then calculate the z in the following formula. So we'll first read that data into our exercise2.csv. And remember to set the working space to the source file. So from this, now it's there. It has x, y, two column. And now we need to generate a third column called z, and that is, so let's first generate that by we first generate this z. And then So although the formula say x, y, z, but because we put everything into a table, so you need to remember in R you have to put table $sign to call those things. And else this will be else if divided by 2. So let's see whether this is wrong or not. Okay, what's a mistake? I didn't put I here. I should put I. It's very easy to make this kind of mistake. So let's run this in here. Okay, so then you can verify whether this indeed is correct or not. So these are the same. So what I'm trying to do here, this one are basically, so there are three, so I guess if I don't have to do this, okay, this is probably a little too advanced. Let's do it more kind of more step, using more kind of more wordy way. The way I'm writing kind of probably have a little jump for you right now. So let's do it this way. Let's just put it outside, and then else if it's greater than that, okay, so this is probably more easy to understand instead of writing it by default. That's a faster way since I kind of do it by habit. But this is probably more intuitive to understand. So we read that. So first when we read that file into R. So it's basically a table with X and Y in columns. And now I need to calculate the Z, so I first just generate something which is completely zero. So here, I basically give a value of Z, but right now it's just nothing there. But I'm going to calculate something for the Z. So first, this is just to initiate empty place to store the. So then I look over everything to calculate the Z based on this requirement. So if X is larger than Y, I calculate it this way: Z equals X minus Y. Else if I forgot actually to type it. Else if TB X less than Y, and then it's minus square root of this. And if they are the same, and calculate half of that. So basically, that's the algebraic definition, but you have to translate that into the syntax in R. So questions?
No, just
That's yeah. I actually put everything on video to upload. It's not very clear on the screen, but at least you can hear what we are talking about.
Okay, so that's very great.
Yeah, but I'll also do a webcasting on this.
Okay.
Let me just put this way. So, okay, so this question is, we have a small Excel data file, and this data file contains 2 columns, which is 2 vectors, x and y. So the question asks us to calculate a third variable z using the following conditions. So if x greater than y, v is the difference, and if x less than y, and then it's a square root of y with a negative sign. If they are the same, and we calculate, say, negative x divided by 2. And finally, we need to output this file. So we first read into this data info file. Remember to set your working space into the source file. That way you can read the data into R. And so run that. And in fact, now if you click on the right hand, you will see the data there. And now to start calculation, we first set empty value of z. So it will first have a z there, but right now it's just nothing. So I run that, you click on the table again, so z is just empty value right now. And then I basically translate this requirement, say x and y greater than y, translate that into the syntax in R. Remember in R, I have to call every vector in the table by the $sign. And then for each element, I have to use the index, a square bracket index, to loop over every. So the I from the first one, 1, to the last one, then that's the, I go from the first one to the last one. And I is my finger pointing everyone from first one to the last one. And every element is xi or yi and di. So basically translate these algebraic conditions into this R statement. So I run everything, it should generate. Now you go back to the hurricane. Yeah, so we can double check that probably is correct. So, and then we output this. How do we output this? We use write.csv table, and this one we say, well, output CSV. In fact, that's what we're doing. So run that. And then we go to the file, see, yeah, it's already there, output.csv. It can be read by Excel, so I just double click and see whether it's output there. There, okay, X, Y, Z, and values. So number 3. Number 4. We are given a sequence file and then found out the fraction. That's basically the class, again, is a classroom example. So let's go back to the sequence example again. I'll probably still in this basic part. It's basically the last part of the sample training. So you need to install those. I'm going to copy paste those just back into the. So I'm going to load I don't think I need that. Load the packages. And we don't need help. And sequence read the FASTA. This time we just read the file directly. That sequence called sequence.csv. Oh, I actually directly give you a sequence in the table format, so we can just read the csv.sequence.csv. So that will make it much easier. And in fact, we don't even have to do that now. So we don't even have to use this package because it's already in CSV format. So this one will basically ATCG. So how do we count the frequency? We just count by using a table command. That will be table first column. Run this. Oh, I typed it wrong here. There. So found out the fractions of ATCG. Now that's a table counting that, and if I divide it by total length of that, that will become a fraction of it. Right? So now it's have a fraction of say 25%, 22, 29, and there's also like the 1.8% of nucleotide which is not ATCG. That's the first one. The second one says generate random sequences. We actually didn't go through this part. Basically, using a command called sample. So once you sample that, it will be just a random sequences. Sample basically. This sample command we didn't go through this time, so obviously this part won't be in the exam. I'm just going through it to show you what's actually how to answer this question. So sample yeah. So sample takes a sample of specified size from the element of X using either replacement or without replacement. So what this command does say, let's say we have initially we have some numbers, say A, B, B, A, T, G. Well, let's use nucleotide. C. So let's just still using. So this is the original, and what sample command generates. Let's say this is a random sample. You just say I'm going to randomly pick one. I'm not looking at pick one. Okay, and then I put it here. I'm going to pick another one. Okay, put it at second place. Pick another one. Put that at third place. So this will be A. So that will be G. This would be A. This will be G, and then C.
So you can choose the same one twice?
Yeah, this will be replacement, yeah. Sample with replacement. You can also do sample without replacement. Sample without replacement, that's actually there's a perfect term, that's called permutation. You basically, like a deck of a card, you just reshuffle it, that's permutation. That's also sample without replacement. Exactly the same thing. A sample with replacement is more like, like how do people picking lottery number? If you put that number back, that is with replacement. You allow replacing. You can sample things twice. Sometimes in some situation it makes sense. In some situation you don't put those numbers back into the pool. You just sample the rest of it. So basically, I mean, you pick random things and then put it back. So that's what. And then you can do it again for the next random. The first one, you can do it again for another one. Yeah, so this actually, in biology, there's actually a name for this. This is also called bootstrap. I have no idea what this name came from. But this process is also called bootstrapping biology, especially in bioinformatics like sequence analysis. Sometimes you heard people say, the bootstrap is basically a way to say, we have, I heard this joke before, why it's called bootstrap? You heard the idea is like you try to pull yourself up by pulling the bootstrap. It's a bad analogy because there's no better way to do this. But
Can you
yeah.
explain replacement and non-replacement?
Okay. So let me just write it here. Replacement. You can sample the same thing again. Basically, can pick same thing more than once.
So what you just did was a random selection with replacement?
Correct.
Okay.
Non-replacement.
Can we use our studio tool without replacement or with non-replacement?
Right now the replacement is false, which means sample with replace. By default it's always false.
Which means it's non-replacement.
Which means it's just permutation.
Okay.
Yeah, by default it's false. So if you change that to true, change this to true, it will be sample with replacement. So by default it's always permutation. That's just it. Every item is picked exactly once. Pick exactly once. So basically, it's kind of shuffling your card. You just randomly shuffle your card. This one somehow magically can use the same card twice. It'd be wonderful. Basically, you are, if you really are playing a card, that's kind of cheap. You can use the same card twice. So, yeah. It depends on the situation. So, okay, yeah. So, in biology, we actually we actually can sample it and replace. That's actually meaningful in biology, because if you think about evolution, they don't just pick exactly the same thing once. I don't think that makes sense. Actually, you think about if you think about the genes of kind of glass balls floating around in everybody's body, our gene is really DNA, but DNA is basically a discrete item. You can either have it as A or T or T or C. It's basically a fixed. You don't change those things, right? It's more almost like those Lego block display, and you can picture that's how our DNA works. And the block can be red, blue, yellow, green, and simply by chance, right? But you think about after one generation, the children basically randomly picking those blocks and putting into their own body, their own genome. They can pick those blocks multiple times.
Okay.
So, well, every kid only have one chance, right? But if a family have multiple kids, there should be multiple chance. Doesn't mean each kid has exactly the same. In fact, if you have 3 kids, for sure they are going to share. Right. So yeah, basically that's what. The genetic unit is a discrete item. You can sample it multiple times. That's what happened here. So we sample it with replacement. We can call that sequence 1. And that will be the first. Basically, if you picture that's the parent. Well, in this case, it's a single copy, so it's more like E. coli. And then the second one will be another bacterial split. This time, it has some random mutation here. So you can actually do this if you in the past when students cannot write a loop. I give credit when students just write this 10 times. We're kind of a naive way to do this. And you do this 10 times, and then in the end, you basically put it into output. Put everything into output as sequence 1, sequence 2, sequence 3. You can do that. And then just write it out. But, alright, so you just do it 10 times. Or you can use a for loop. So we can use a loop. So we say for 1 in I in 1 to 9. So in this case, we still do that. So in this case, we do a sequence I equal. I can just sample sequence 1 again. Replace. But how do I put it into the output? I basically say output equals C bind output sequence I. This way how I can put it into table. So let's see whether this works or not. So if I do that, oh, it's probably okay. Let's do this. Oh, I must have a typo. C bind, column bind. So what C bind is? It is bind everything by column. So you can bind by column, you can bind by row, row bind, column bind, or row bind. Yeah. So in this case, we put everything vertically, column bind. Yeah. So we run that, look at output. Yeah. Oh, except right now it's treating everything as a number. Let's see. Oh, it's treating everything as a number. So table. Sometimes in R it automatically converts the string into a number because R is a statistic originally designed for statistic purpose. So it's kind of annoying, but so sometimes we have to manually convert it back into a string. Especially in biological sample, we want to work with DNA sequence. We have to do that manually. That's just the annoying feature. Let me see whether this is changed. It doesn't seem like it changed that. That's probably because I put this as sequence 1. If I change this into table 1, that's okay. Oh, it's still factor. That's strange. Wait, it didn't change. Oh, I typed it wrong. That's error. Yeah, now it's changing now. So. Yeah, so now it's 80. And then you can just output it. Okay, let me also do a review of the current one again. Okay, so the first sequence, for this question, we did a DNA sequence file in CSV format. So once we read into it, we make sure the sequence are read the characters and not numbers. And then the key is to remember to use the R command table. It's heavily added occurrence. So in this case, if we just run the table directly, it's just counted the occurrence of A, C, G, T, and in this case there are also ends. Apparently this sequence has some low quality information. So when the sequencing machine cannot tell whether it's AT or CG, and they put an N there. So those are the frequency that counts for every nucleotide. But the question asks for fractions. I guess the question asks for the fractions of each nucleotide. So what we can do is just the length of this table is basically the number of nucleotides in that sequences, and we divided the total occurrence by the total. We divide each nucleotide by the length of these sequences, and then it will be just a fraction of it. So there. the nucleotide by interaction. So for the second part of this question, you are asked to generate a random sequence based on the first sequences, and then write it into a file. So the key is really to use this function in R called sample. Sample by default is sample without replacement. I forgot to put a sample there. Yeah. So by default, it's sample the without replacement is basically the permutation. But in biological sequence, we want to do sample with replacement, so we change this to true. So if we want to generate 10 random sequences, if we do it naively, we can just generate 10 random sequences, sequence 1, 2, 3, 4 to 10, and then we use a C bind, which is bind by column, and then put everything into a table, and just write that one out to a CSV file. Now, you actually will get a full credit if you do this, but there's a reason why we are doing it. Write a code. That's what we are using a loop. So if we want to use a loop, we can still use the sample command. Start with the first random sequence, and then we have 9 more random sequence to generate. So now we first also put out the first sequence into an output table. We still use a C-bind. In this case, it's just one column. And then we use the loop, say I from 1 to 9. So we want to add 9 more random sequences. And still call this sequence again. This time we don't call sequence 1, 2, 3, 4, 5 anymore, and since it's going to be a loop. So I just call it sequence I. And then after generate, I just put the sequence I into the output file using the C-bind again. Except this case, I always put an extra column into the output table and then put everything again back into the same output file. So after that, we can just write this one out, right? I'll write CSV file, output of sequence CSV. Then that's just write everything out. Practical exam. Yeah, for this practical exam, that's basically we have to. Let's look at the different one. Oh, I see. That's basically exam 1. That's just it. Let me just. For some reason, I cannot attach. I haven't figured out a way to attach a file when I give the exam. So I had to put the file Moodle just right below it. That's way. Yeah. SBIO. Yeah, so I'm going to just remove this one. There's just nothing there. That's just a title, say the next one is the practice. So, and 1. Okay, so this is just an exam, various exams from several years back. So this one, well, you can look at the instruction. Oh, that's actually in the screen. So 5 problems. You must show your RCode and running result. For some question, you need the necessary some more explanation to get proof better. You have 2 submissions. First submission due February 13, count for 20 points. Second submission due February 15, count for 80 points. No. Then there is some explanation how do you compress file into a single zip file. So let's look at the first one, regression. Oh, so this question actually asks you to go to a website, download the file, and then use regression to do analysis. So you can actually directly read that file. Let me see whether I can directly read that file. Good. So you can just directly copy paste that file into a readout table. You don't have to even download it. Let's see whether this works out. Yeah, you see, it works. Oops. It works. Clear everything. Run it again. Yeah. That's basically, that's actually a real data generated in my own lab. So what this data means is there are various yeast strains. Those are the net sample size, RLS for replicative lifespan, and then those are various other parameters. So we will actually discuss this more in detail once we start the cross research project. But right now, this question basically asks you to run a linear regression to see whether there are some association between lifespan, parameter A, and parameter B. And draw a diagram as an example. Oh, this question was given because in this part, this example was given after we discussed that science paper. So, and then generate a histogram. So this was so of course this kind of question won't appear in this class since we haven't even discussed that paper. Yeah. But it may occur in the second exam after. It should actually, it will definitely occur in the second exam after we discuss the science. So you basically use regression to do this. And in fact, this should be done by multiple regression. And that's it. This should be good. That's it. Yeah. So there is negative correlation between A, B, and lifespan. And then you give me the p-value and r-squared. R-squared is extremely good. 0.833 for biology and lifespan, and this is really amazing. So I'm really proud of the quality of this data. So, yeah. The second example, let me see, question 2. You are giving a yeast gene table in a file, my CD, This is packed in the file, 3 columns in this table, status can be independent. This is basically a question to see whether you can use the bracket to index each value. Let me see. So you read it into the table, and then for the first question, you just use the table command again. And if you use table command to find out that's probably chromosome or something, or status. Status, yeah. Status. This should do it. But that's we just tabulate everything. The second, this one basically have to something like this. Have to be table y f equal is y a l greater c. So bracket is double equal sign, and you show all the values in the 3999 row. That's basically it. Basically, this question basically asks you to do some very simple index. Okay. Number 2, number 3. That's again, number 3 is exactly the same question. Yeah, so we don't have to go through this again. So. Number 4 is a loop function. Basically the same question. I just changed the algebraic relationship. Instead of x minus 1, I say x times y, and then flip some orders of this. Basically the same thing. So matching. The 5 question is again based on the science paper, so we don't have to go through that. Yeah. So that's based on the science paper, so we don't have to go through that. Oh, that that's nice. Yeah, actually, this is seem to be. Yeah, you should. Wait a minute. Yeah, I'm going to let you work on this one and then ask me a question, because that's basically very similar to what the question in the exam. I can even show you what the exam going to look like. So exam 1 is basically based on the salary example. First question, yeah. So the second question again based on the molar solution example. And the third example very similar to the XYZ again, I think. Let me see.
So are you saying that for our test that we're getting ready to take later on this week?
Oh, I'm going to give this after the class will be due on Wednesday.
Oh, okay, and that's the test that you're going to do today?
Right.
That'll be on Wednesday?
Yeah.
And it'll have salary, molar.
Right, yeah. And loop and if statement, plot, save figures, plot something and save it to a fixed Word document.
Okay.
And then how to write a function and generate output. Yeah. So yeah, that is the exam. So it is an independent exam even though it's take-home, but it's due Wednesday before class, and then you can do class work on it at the collaborative exam for the second class.
Okay.
So you have 2 strikes. So Wednesday we basically have an in-class exam to work on it. You have another chance to work on it again.
Okay.
But your the first chance is independent. So it's basically the same thing. Yeah, and those are the skills will be tested. Input data into R, set working directory, output R into files, basically CSV files. How to use a linear regression, found out an R square and p-value. Do a t-test, use table function, use double equal sign to find something, indexing, scope, for loop, while loop, functions, plot, save figure to work. And those are basically key skills will be tested. I mean, I'm not testing every one of them. I should. Yeah, I'm not. Sorry, okay. Yeah. Okay, so, but since I'm not going to show you what's in the exam, you should work on this exercise. So if you can do this exercise, you should have no problem to work on it. So, and let's work on it. And ask me question. Yeah. So yeah. Basically, I mean, you should work together because I mean, you shouldn't work alone. Okay. The first question, yeah. Let's work on the first question. In the salary data, found out using linear regression to find out whether salary and the year has something to do with each other. What's the R square and P value of that? Okay. There's a difference between your code and what I written on the board. Where do you see the difference? I'm highlighting the differences here.
The difference is there.
Yeah. And that actually will cause a mistake. Right, yeah. What's the difference there? Because if you change that total outside, let's say it's 100, then it's not going to sum up from 1 to n. You sum up 1 to n plus 100.
Okay.
Yeah, see?
Okay.
Yeah. So.
So I understand the function.
You want to really write it using a format that looks like. Actually, see, that's a problem. When you write it in a format that you actually put things outside. So make sure you want to write it in a format that looks clear to yourself. So if you put things just so it's actually a good practice just to put a curly up over there and down there and put everything indented. That way at least you know where your curly is. That's a very easy way to catch mistake.
Is that saying total plus 2?
No, plus I. I, sorry. There's a dog have that.
I
Yeah.
have a concern. Why won't and I define my function?
No, you did not define your function in the correct syntax. Look at what's on the board. There's something missing in what you written there compared to what I written on the board.
Besides ourselves?
Yeah. You didn't define it for the You just call some function. There's no, you have to assign it to a name. See the difference? I say our sum equal function. Function is a way to write function, but you just write a generic function without assign to something you can do. Okay. What else is missing? See whether you can
Is that right?
yeah, it runs, but how do you see the result? You haven't, you just define a function, you haven't run that function. How do you call that function? To sum the x. You have to, so when, if you just run that function defined, you haven't called it yet. Call, it's probably either call say 2. 2, yeah, that's 2. Okay, yeah, see, it's not making sense.
Yeah, I think I'll be in the terminology, some of the like calling and some of those terminologies and stuff.
Oh, I see.
Yeah.
So, yeah.
Let me see if she makes my stuff not working.
Okay, I guess when I say call a function, use a function, it still doesn't talk to you intuitively what I mean. Because, yeah, it need to take a while. Let me look at what you have written. Okay, I guess I didn't say which order. This is definition of a function. The definition actually should go first, and then you run it. So if you want to see whether it's doing something correct or not, you try. Oh, no, how? When should be one? Should be 3, should be 6. Okay, it's doing something correct. 6. Yeah, it seems to be doing something correct. Okay, good. Yeah. So, yeah, so if you are not sure whether the function is making sense or not, run something you know what is the correct answer, and then see whether it's returned the correct answer. If it's not, then something is wrong. You have to go back and check it. That's basically the general principle to write any software. You first test something you already know what's the correct outcome the software is supposed to do. If you cannot even do what's a simple example, then there's something must be wrong. So,
I don't see this one. Dr. Chen. What exactly is it supposed to be?
It's just calculate, you write a function to calculate the sum and then do it right.
Is it for the values from the one?
Yeah. But you just change the number of names. You cannot say yeah, that's it. Yeah.
So it's not supposed to add up these individual numbers? Okay.
Yeah, that's right. Yeah.
So how would you do a loop to add up just those individual values?
Oh, then you have to do it individually. draining the memory. It's really, that's why it's responding so slow.
Oh no, it's like a little button on the side.
I
I'll hit by
see.
accident.
Okay. I see some of you have many windows open using RE. It's really you really don't want to do. That's a bad practice to use a computer. You want to close all those unnecessary windows and then just do, at least so the current window actually the software you are trying to do at least is working there. Okay, so then
Oh, you just have to drag it real lightly. You don't have to push it whole clean.
yeah, how about you say clear everything? And then rerunning. Okay, let me see. See, now it's working. You just type, yeah, now it's working. Something is really clear.
Can't say much.
So, if it doesn't work, sometimes you just clear everything with sometimes, yeah. If you really want to add up anything like that. Okay. Yeah, this should work. It should work. Yeah, have you tried? Yeah, it seems to be doing something correct. Oh, you type R. So there's no N here. So you type R. Here, this is not N, this is R. You type R. Here. Line 9. Yeah. Make sure you don't have typo in your code. I know that's actually a common problem when you write your code. Somehow everything seems correct, but and that's a common problem. I also have that problem, and it's basically when you write things yourself, you just even though it's obvious, when someone else look at it, it's obvious typo. It's very hard for yourself to see that typo. Sometimes that happens, yeah. But that's actually a common problem when you write a code. Yeah. So sometimes in Silicon Valley, they are now some company promote the something called a paired programming. It's because you can easily you can more effectively spot a mistake which one person sometimes had a hard time spotting. This must be an interesting psychology. Yeah, so okay, it looks like most of you have worked out this one. So okay, so I think there's another exercise you should work on. Is just to plot a figure and save it and plot it into a Word document. That's one of the questions in the exam. Generate a plot and then save it into Word document.
So generate a plot and save that as a Word document?
Yes.
That's just
Any plot, histogram or scatter plot.
for what data though?
Well, you just generate the Okay, let's just do this. You can use any data. We just generate some data, right? You just generate, say. Okay, let's do this. X equal 1 to 100, and y equal square root of x, and then plot x and y, save it in a Word document. Yeah. This.
Question 2.2 is variance the same thing as standard deviation or
Question 3.2.
2.2 it says just define the mean, and variance. Is that the same thing as
Oh.
standard?
Yeah, standard deviation. Although variance is actually the square of the standard.
Sigma square.
Just
So which one would you want? Would you want variance? Would you want
standard deviation. There's a question say generate a vector. How do you generate a vector? You basically write a C. Right. You basically type it in. So x equals C, that number, say 3.5.5, I don't know the number, yeah. And then you just say mean x, median x. I forgot the command for standard deviation.
SD?
SD, yeah, SDX, yeah. Very good, thanks. So, okay, it's almost 12. I'm going to go over the exam now, but I'm not going to answer any question about the exam, except the question of, sorry, what?
Oh no, I'm sorry. Could we go through 2.3?
Sure. 2.3, a function is defined as this. Write our function to increment this, and calculate this for value for x bar. Oh, okay.
So would you like to use a loop first with conditions in it?
Yeah.
In the first part of the function?
Okay. So I'm going to, yeah. So I'm going to put a question there. Define this from x this, when y is that. Write the function, increment function for x value. So x equals 0 to 6. And then I write a function to do, so I'm going to say say test from equal function input x. Well, to avoid confusion, I'm going to call this x input. So that way, maybe it's more easy. Okay. So if x for I in 1 to length x, if x I less or equal than 3 is something else. Well, else means it of course is just will be greater than 3. So then Oh, this one had to return it for something else. So this will be just y output, x input. I'm going to. This is just a temporary buffer. I'm going to do a calculation, but that's just output. So y out, that's y out, I equal 3 times x input I plus 2, and else will be y out I equal 2 times x input I minus 0.5 times x I square root 2. And then at the very end put the y out there. And then as I test for x, this should work. Let's see whether this works. Yeah. So you can test whether this is correct or not. Okay, just to tell you what I've so in R, so what I'm writing here is just to teach you to do programming. In R, there are actually more technical way to write it. It's something called vector programming. So it is actually the strategy in R is say you want to avoid to write a loop if you can. If you can do it in a single line, that's always better in R, supposedly. But it's but my purpose is not ask you to teach you to write advanced R code. My purpose is just to use R as a general tool to write programming in general. I'm not teaching you to become a professional R developer. I'm teaching you to become a programmer, know how to computing in general. So I'm not writing you to in a specific R advanced technique. So be aware of that. Yeah. So if you look at some of the example in other books, why don't you never tell us to write that? There's a reason behind that. Yeah. So.
Now, I do have one question. With
Yeah.
yours, okay, I know you did the else just for like it to be all other cases, but could you have done like an else if for it or not? Is that not working hard?
It could, except the x is the first one say x is less than or equal than 3. Else it can only have one choice greater than 3. So I don't have to do else if x greater than 3. Yeah. So this is basically by default is no other choice. Yeah. Although this could possibility say someone input x as a text or something.
Yeah, like if X is Y.
Right. Then but in that case, you have to do a catch error. Say if x is a text, you do something else. Let's say you input something wrong, please input an error. But that's a more complicated issue. we assume at least people know what they are doing here. Yeah. So yeah. Okay. Let's go with the exam question. So if you have questions about what the exam is asking for, I can answer that question. I'm not going to explain what you. So yeah. Okay. So that's the first question. So I even give you the starting code. So you read that data, and then I ask you whether there is a linear correlation between salary and the field, and then ask you to find out the R-square and p-value. So this is really straightforward. You just do a linear regression between salary and the field. And then I ask you how many female and male faculty in the field of an art professional and others. Okay. You have to figure out a way to do this. Then calculate the mean salary in the field for art and the professional. And then test the then I ask you is there a significant difference between between them, between these two salaries. And then explain what is the H0 versus H1 in there. With respect to the question, I'm not asking for a general definition. So, this is the first question. Second question. This is really a given issue. So, ask you to write one or multiple functions to calculate the amount of chemical ingredients need micromolar solution for couple solvents. Now, here's the catch. Your input volume should be in millimolar, and your concentration should be in molar. So it's a little bit different from the what we're working on. Just input value I changed. Right, so. And the third one is, well, I give you a vector. Vector of x, and you need to modify this code to just print out every x, every element of x, and you need to modify those. Those question marks should be gone for your code to work. So number 3, that's number 4. Oh, plot and you just, I give you the data, you just read it in plot it and insert in our document. Is that it? Let's see. Oh, there's another one. Aha! This one is probably the most adventurous one. So this time I give you a function I just found out on Wikipedia. It's called exponential growth function. It's defined here. Xt equals x0 times 1 plus r, that's the exponential growth rate, and to the power of t. So then the question is, you write a function there. The t basically is something, say 1 to n. How many generations? T is the discrete number of generations, basically. Yeah, t basically, t equals 1, 2, 3, like 100, 200. T is basically a discrete number here. It's not continuous number. So basically that's it. So write the exponential growth function, and then calculate it for x0 equal 1, r equal 0.1, and t equal 1, and then t equal 2. And then you do this for t to 1 to 100, and then output your file into a CSV, output your result to a CSV. So this is probably the most challenging one. Okay. Do you have any question about what the exam is asking you for?
Wait. Yeah. You said exponential growth is not enough?
Sorry, what?
You were showing us exponential growth, but is that like credit or exponential growth?
It's one of the questions. The fifth question.
Can you go back to that last one you just did? I think you also said take that equation and like write it into a function.
Yeah. This is just Wikipedia tells you what its exponential function is.
Can we practice that?
No. We have practiced on other functions, but this one, you should first work on your own. And on Wednesday, we work on it in class. Yeah, so. Okay, if you have a question about the question, I can explain to you. So, but now you should work independently on the exam. So I'm going to post this after the class, and it will be due Wednesday before class.
And so then Wednesday, if we like have like ones that we couldn't figure out how to do, we work with each other too.
Yeah, Wednesday is collaborate. You work.
But we submitted before
right?
That's
After I
right, yeah,
already
submit,
did.
right, yeah. Individual and submit before, Wednesday before class, and then you work in class. Yeah, we'll figure out that. I will, if I see there's a general problem, I will give you a hint, tell you what's the right direction to go.
Okay.
So,
Could you go back to the R studio real quick?
sure.
Oh yeah, I just need to copy that rest of it.
Okay, sure.